Hi, friends. Welcome to our lesson. I'm Mrs. Gradney, and today in our lesson, we'll be creating equivalent fractions in a new way, this time using area models and division. Now, we've been creating equivalent fractions using area models and multiplication. How do you think this will be related to that? Well, let's get started and find out. In our previous lessons, when we wanted to create an equivalent fraction, we started with a larger unit and decomposed it or broke it into smaller units to create the equivalent fraction. Like this, we could take 1/3 and decompose it into smaller units to make the equivalent fraction. So now we have 6 smaller units in the whole and 2 smaller units selected. So we've created the equivalent fraction 2/6, and 2/6 is equal to 1/3. Now, do you think that we could start with the smaller units and somehow create an equivalent fraction with larger units? How do you think we might do that? Hmm. Pause the video and talk out what you're thinking. I was thinking that it makes sense that if we can take a larger unit and break it into smaller units to create an equivalent fraction, then it makes sense that we could take those smaller units and put them back together and make larger units to create an equivalent fraction. Is that what you were thinking? Well, let's give it a try. Take a look at this area model. What fraction is represented in the model? 6/12 is represented in the model. Do you see any fractions equivalent to 6/12 in the area model? Well, I can see that half of the area model is also shaded. So this model also shows 1/2. Now, which are the larger units, twelfths or halves? Halves are the larger unit for sure, right? This is the size of one of the twelfths, and here's the size of one of the halves. So let's circle the smaller units, the twelfths, to make the larger units, the halves. If we circle these 6/12, that makes 1/2. And if we circle these 6/12, that makes 1/2. So what are the equivalent fractions that are shown by this area model? 6/12 equals 1/2. Great job. Let's think a little bit more about what we just did. When we composed those fractional units, when we put those fractional units together in groups of 6, what happened to the size of the fractional units? Pause the video to talk out your thinking. When we composed those fractional units, they got larger. Here's the size of the twelfths that we started with, and here's the size of the halves that we composed. The halves are definitely larger than the sixths. When we composed the fractional units, what happened to the number of units in the whole? Well, to start, we had 12 smaller units in the whole, and when we composed groups of 6, now we have 2 larger units in the whole. So we have fewer units in the whole. What about the number of selected units? Well, to start, we had 6 smaller selected units, and when we composed groups of 6, now we have 1 selected unit. So we have fewer selected units as well. How can we be sure that 6/12 is equal to 1/2? Pause the video to talk out your thinking. Hopefully you noticed that the shaded area of our model didn't change. We didn't shade any more or any less. Now we have 1 larger sized unit instead of 6 smaller sized units, but the shaded area is the same. Now let's express the equivalence of these two fractions in a division number sentence. Write along with me. We started with 6/12. In the beginning, we had 12 units in the whole. Then we composed groups of 6 And now we have 2 units in the whole. In the beginning, we had 6 units selected. Then we composed groups of 6. And now we have 1 unit selected. So we've shown with division that 6/12 equals 1/2. Now, why does this make sense? Pause the video to talk out your thinking. You may be thinking, this makes sense because in our last lessons, we made more smaller units by decomposing larger units into smaller units. And we multiplied to show that. This is just doing the opposite, so it makes sense that we divide. We're taking smaller units and grouping them together to make fewer but larger units. Or maybe you're thinking about what we know about division. We took 12 units and made groups of 6. When we have a total and we're making equal groups, it makes sense that we're dividing. Great thinking. Let's try another one. Pause the video and draw and label an area model to show 2/8. Try to make your units as equal as you can, but remember, it doesn't have to be perfect. I'll be waiting when you get back. Here's my area model showing 2/8. Your area model might look a little bit different, and that's okay because there's more than one way to show 2/8 in an area model. Just make sure that you have 8 units in the whole and 2 units shaded. Now, how could we create equal groups in this area model to compose a larger unit? We could circle groups of 2. Let's do that. Now, when we compose those groups of 2, when we compose the fractional units, what happened to the size of the units? They got larger. Here's the size of one of the 8s that we started with, and here's the size of the new fractional units that we composed. When we composed the larger units, what happened to the number of units in the whole? Well, in the beginning, we had 8 units in the whole, but when we composed groups of 2, now we have 4 units in the whole. So we made fourths. We have fewer units in the whole. What about the number of selected units? Well, in the beginning, we had 2 units selected, but when we composed groups of 2, now we have 1 larger unit selected. So what fraction is our area model showing is equivalent to 2/8? 2/8 equals 1/4. Now let's show the equivalence of these two fractions using a division number sentence. We started with 2/8. In the beginning, we had 8 units in the whole. Then we composed groups of 2. And now we have 4 units in the whole. In the beginning, we had 2 selected units. Then we composed groups of 2. And now we have 1 selected unit. So we've shown with division that 2/8 is equal to 1/4. Let's try another one. Pause the video and draw and shade an area model that shows 3/12. I'll be waiting when you get back. Here's my area model showing 3/12. Remember, your model might look a little bit different, and that's okay because there's more than one way to show 3/12 in an area model. Now, how could we compose these 12ths to create an equivalent fraction? Pause the video to talk out your thinking. At first, I was thinking we can compose groups of 2, just like we did in this one. So I was kind of imagining circling those groups of 2, and then I realized, one of the groups of 2 would have 1 shaded unit and 1 unshaded unit. So that won't work. And then I thought, well, that actually makes sense. because 2 is not a factor of 3. Nothing times 2 gives us 3, so we won't be able to divide 3 by 2 evenly. But groups of 3 will work because 3 is a factor of both 3 and 12. 1 times 3 equals 3, and 4 times 3 equals 12. So let's circle groups of 3 to compose an equivalent fraction. What equivalent fraction did we make? We made 1/4, so 3/12 equals 1/4. Now pause the video and let's express the equivalence of 3/12 and 1/4 in a division number sentence. So write the division number sentence to show that 3/12 equals 1/4, and we'll go over it when you get back. Welcome back. Here's how we could have shown that 3/12 and 1/4 are equivalent using division. Compare your work to mine and make any changes if you need to. Now, how does our division that we did here match what we did in the area model? Well, in our division, we can see that at first we had 12 units in the whole, which is what we had in our area model at first. Then we made groups of 3, which is why we divided by 3. And now we have 4 units in the whole. Then we thought about the shaded units or the selected units. At first we had 3 shaded units, which we can see in the area model. Then we made groups of 3, which is why we divided by 3. And so now we have 1 unit selected. Great job. Now compare the area models for 3/12 and 2/8. What do you notice? Pause the video to talk out your thinking. You may have noticed that they both equal 1/4. But we composed groups of 3 in 3/12 to make 1/4, and we composed groups of 2 in 2/8 to make 1/4. So we composed both 3/12 and 2/8 into the same unit fraction. Way to go! Let's try one more. Pause the video and draw area models to show 2/6 and 4/12. Then circle the groups to rename both fractions as the same unit fraction. I'll be waiting when you get back. So what unit fraction did we find is equivalent to both 2/6 and 4/12? 2/6 equals 1/3 and 4/12 equals 1/3. Way to go! Now pause the video and write a number sentence using division to show the equivalence of the fractions for both of these. You can compare your work to mine when you get back. Welcome back. Compare your number sentences with mine and make any changes if you need to. Now, using our area models and our number sentences, how are 4/12 and 2/6 related? Pause the video to explain what you're thinking. Maybe you said that in our area models, we can see that both 4/12 and 2/6 have the same area as 1/3. Or maybe you were thinking that in 4/12 we composed groups of 4, so we divided the numerator and the denominator by 4 to compose the fraction 1/3. But in 2/6 we composed groups of 2, so we divided the numerator and the denominator by 2 to compose the fraction 1/3. But for both of them, we composed the same unit fraction. Excellent work today, friends. I think you're ready for the problem set. On the screen are the must-do problems. Work on these